In this lesson, we're going to talk about learning how to graph lines by plotting points. Now, typically when you have a section like this, what the directions are plug in three numbers for either x or y, and hopefully you don't get a fraction. If you get a fraction, plot the fraction, or just pick another point that isn't a fraction. So let's just try doing this problem the way it's normally taught and say, let's just pick three random numbers. I'll pick 0, 1, and let's just pick 3 for the y, just to demonstrate that you can plug in a point for either the x or the y variable. So these 3 points, 0, 1, and 3, I'm going to highlight them so remember that these are the points that we initially plugged into our equation. So basically, this table is 3 different problems. The first problem is x plus 3y equal to 6, except what we're going to plug in is x equal to 0, and we're going to figure out what that value is. The second problem is this one right here in the middle. We're going to take the same linear equation, x plus 3y is equal to 6, but this time we're going to plug in x equal 1. Okay. And the last problem that this turns into is x plus 3y is equal to 6, that's the exact same equation, and we're going to plug in, instead, y equals 3 this time. Now let's solve each one of these problems. When I plug in 0 into this equation for x, I get 0 plus 3y is equal to 6, 3y is equal to 6, and when I divide both sides by 3, I get y equal 2. That means that when x is equal to 0, y is equal to 2, and this coordinate 0, 2 is on my line. 0, 2. Okay. Now let's do the same thing for the second equation. This time we're having x equal 1, so when we plug 1 into here, I'll subtract 1 from both sides. And now I get a fraction. And typically when you get a fraction in these problems, it's good to turn it into a mixed number. Now, depending on your personality, when you see a fraction, you may just say, you know what, let me do another problem because I hate fractions. Let's say you're brave and you decide that you're actually going to graph the fraction. You actually can. Now, the x is 1, and 1 2/3 is basically in between 1 and 2. And I can put up a little point right there for 1 2/3. I'm sorry, 1 2/3 is between 2 and 3. Now, for the last equation over here, we're going to plug in 3. X plus 9 is equal to 6. And then we can also plot this point. 1, 2, 3. 1, 2, 3. Right here. And in theory, this should give us a line. Now, the reason why we plotted 3 lines is, well, most of you guys are just learning algebra and you aren't great at it. You make mistakes. You only really need 2 lines in order to draw a line. But if you do 3 points and they're all lined up, you probably did it correct. If you got 3 points and it looks like a triangle, you probably did something wrong and you should redo the problem. So basically, that third point is just for error checking. And now this line is your answer. Now, if you're comfortable plotting points just using this technique of either plotting fractions or trying other numbers until you don't get fractions, that's fine. I have a bunch of heuristics to help you in this section so that you can more efficiently guess numbers that don't turn into fractions. Okay. Now, a heuristic is different from a rule or a theorem. A heuristic usually works. It's basically good advice. And I've done this section enough times to know that my heuristics, if you learn all three heuristics, will work for just about every problem you'll see in Algebra 1 and Algebra 2. Now, let's make sure that we understand what the terminology is. The number that's all by itself is the constant. The number that is next to the variables, so in this case you don't see it, but actually there's a hidden 1 there, and this 2/3, those are coefficients. Coefficients are the numbers that are next to the variable, and the constant is the number that's all by itself. Now, in order for us to solve a problem that has a fraction as one of the coefficients, is what you want to do is you want to plug in a multiple of the denominator. So in this case, the denominator of our fraction is 3. So let's count by 3. 0, 3, 6. If the denominator was 4, we would count by 4. 0, 4, 8. If the denominator was 2 or negative 2, we would count by 2's. 0, 2, 4. So in this case, we're going to plug in 0, 3, 6, and we're going to plug it into the variable that is next to the fraction. Okay, so in this case, we're going to plug in 0, 3, 6 into the x, because the x is next to the fraction. Okay, now we're going to highlight this just so we remember which number we started with. So again, this gives us 3 problems. The first problem is plugging in 0 into y equal 2/3 x minus 2. We're going to plug in 0. That's my first problem. My next problem will be plugging in 3 into the equation. And then my last problem will be plugging in 6 into the equation. Now, the reason why we like to plug in a multiple of the denominator is, one is that it will cancel out the denominator. So if we look at this one, these 3's cancel out, and we end up with y equal to 2 minus 2, or y is equal to 0. So when x is equal to 3, y is equal to 0. In the same way, when we plug in a 6, the 6 and the 3 will cancel out, and I'll end up with y is equal to 2 times 2 minus 2, y is equal to 4 minus 2, y is equal to 2. And we like to plug in 0 because usually 0 makes problems easy to solve. So y is equal to 2/3 times 0 minus 2. Y is equal to 0 minus 2. Y is equal to minus 2. And now let's plug in these 3 points. Okay. So 0 minus 2, 3, 0, and 6, 2. 1, 2, 3, 4, 5, 6. 2. Now they all line up in a line, so I probably did this correct. And that's my line. Okay. Now, let's try this heuristic again. Now, this problem is different from our previous problem if you look at the denominator. Okay? The denominator over here is 2. So we're going to enter 0, 2, and 4 into the y, which is the variable that is next to the fraction. All right, so let's try this out. Okay, now we're going to plug in 0, 2, 4. Let's highlight this so we remember which values we started with. And this will give us our 3 problems. 3 over 2y plus x equal to 3. And our first problem says y is equal to 0. That's this one right here. And then on the next one, we're going to plug in y equal 2. So 3 over 2y plus x is equal to 3. We're going to plug in y is equal to 2. And on this last one, we'll have 3 over 2y plus x is equal to 3. And we're going to plug in y is equal to 4. Okay. So the first one's nice and easy. We plug in 0 into the y. 0 plus x is equal to 3. So we get x is equal to 3. In this case, we'll plug in 2. The 2's will cross out, and then we'll subtract 3 from both of them. We'll get x is equal to 0. And on this last one, four divided by 2 is 2. So we get 3 times 2 plus x is equal to 3. 6 plus x is equal to 3, and then when we subtract 6 from both sides, we get x is equal to minus 3. So let's see. We have 0 over here, minus 3 over here, and when we plug in these values, 3, 0 is here. 0, 2 is here, and negative 3 up 4, 1, 2, 3, 4 is right here. And now we're done. Okay, so the first heuristic is if you have a fraction, put in a multiple of the denominator in the variable next to the fraction. Okay, now we're looking at the second heuristic. In our new problem, there are no fractions. So now the question is, what do I plug in here? The next thing I look for is there an x or y by itself? Meaning that, do I have a single variable that has a coefficient of 1 or negative 1? See over here, this x all by itself. It doesn't have a number next to it. In this case, what you do is you plug in 0, 1, 2 in the other variable. Meaning that x is the variable that is all by itself. So you're going to plug in values into the variable that is not all by itself. In this case, the y. So when we do this, we're going to plug in 0, 1, 2 in the variable that is not all by itself. And we pick 0, 1, 2 because they make the calculations easier. Okay. Now, let's give this one a shot. So when I look at this problem, the first problem I have is x minus 2y equal to 1. And we're going to plug in x equals 0 for the first problem. The next problem will be x minus 2y is equal to 1. And this time we're going to plug in, we're going to plug in y equal to 0. In this case, we're going to plug in y is equal to 1. And on this last one, we're going to go x minus 2y is equal to 1. And we're going to plug in y is equal to 2. Okay. Now, in this case, let's solve each one of these problems. We get x minus 2 times 0 is equal to 1. X minus 0 is equal to 1. X is equal to 1. So these are the problems we started out with. Or these are the numbers we started out with. And when I plug 0 into here, we get x equal 1. When I plug in y equal 1, I get x minus 2 times 1 equal to 1. X minus 2 is equal to 1. We're going to add 2 to both sides. Get 3. And on this last one, when I plug in y equal 2, x minus 4 is equal to 1. We'll add 4 to both sides. X is equal to 5. So we get a 5. Now the nice thing about using this system is that you'll see a pattern, right? 1, 3, 5. We're skipping by 2. If you don't see a pattern, then you probably did it wrong without even graphing it. You'll see it just in these numbers. Now, let's look at this. 1, 0, 3, 1, 1, 2, 3, 1, and then 5, 2. 1, 2, 3, 4, 5. I'm counting the boxes. And then up to 1, 2 right here. And this is my line. Okay. Now, let's look at the third heuristic. So the first heuristic was, is there a fraction? I don't see a fraction here. The next heuristic was, is there an x or y that's all by itself, that where the coefficient isn't 1 or -1? And the answer here is no. Well, do the coefficients divide into the constant? And in this case, yeah, it does. So what we will do in this case is we'll plug in 0, 0. Plug in 0 in for x, plug in 0 into y. In these problems, I tend to only plug in 2 numbers because it's hard to find a third number that works that doesn't give you a fraction. So just be careful. So one problem we're going to solve is 2x plus 3y is equal to 6 with x equal to 0. And 2x plus 3y is equal to 6 with y equal to 0. So let's plug this in. 2 times 0 plus 3y is equal to 6. 3y is equal to 6. Y is equal to 2. And in this case, 2x plus 3 times 0 is equal to 6. 2x plus 0 is equal to 6. 2x is equal to 6. X is equal to 3. So when we graph this, what happens is we get 2 points. One point that hits the y-axis, one point that hits the x-axis. In some books, they'll call this graphing by the x and y-intercept. So if anyone ever asks you to find the x and y intercept, and I will in my class, all you ever do is plug in 0, 0, and this will give you the y-intercept. This one will give you the x-intercept. Okay. Now the last point that we're going to have to make, that we're going to have to talk about is vertical and horizontal lines. So when we look at something like this where there's only one variable, the way you graph this is we start out saying x is equal to 3. Now, I don't care what y is. Y could be 1, 0, it could be 1, it could be 2, it could be 18, it could be negative 36, it'd be 17 over 15, it could be pi. It doesn't really matter. But why would you use any of these numbers down there? They're miserable. Just pick something easy like 0, 1, 2. And when I plug in these three numbers, 3, 0, 3, 1, and 3, 2, what happens is that I get a vertical line. Now, this works against your intuition. Usually when you think x, you think horizontal. The way I try to remember it is that when you have something like this, you're going through 3 on the x-axis. Okay, now, for graphing y, where I have only a y variable, you could do the same thing, where y is always equal to negative 4. Or you can just use this memory mnemonic, which I use. Go through negative 4 on the y-axis. So I can either plug these points or go through negative 4 on the y-axis. Okay. Now, we went through a lot of problems, so let's make sure that we remember what questions do we ask ourselves. The first question we ask ourselves is there a fraction? If there is, we use a multiple of the denominator. If there is no fraction, the next question we ask ourselves is 2, is there an x or y by itself? If there is, we plug in 0, 1, 2 in the other variable. Three, we ask ourselves, okay, if there's no fraction, there's no x or y by itself, do both coefficients divide into the constant? Coefficients. You read that? Divide into the constant. And if they do, use 0, 0. Okay, so go ahead and pause this video and don't actually graph these. Just work on what numbers would you plug into each one of these linear equations in order to get an answer. So go ahead and stop the video and try it, and I'll give you the answer. Okay, now that you tried it, let's look at each one of these. Let's go through our questions. Is there a fraction? Yes, there is. All right, let's do a multiple of let's plug in a multiple of the denominator, 0, 4, 8, and we're going to plug it into the variable that's next to the fraction. Okay. Now in this case, let's walk through our questions. Is there a fraction? No. Is there x or y by itself? No. Do the coefficients 5 and 2 divide into 10? And the answer is yes. So you're going to plug in 0, 0. Let's try this one. Is there a fraction? No. Is there an x or y by itself? Yeah, I have got this negative y all by itself. So I'm going to plug in 0, 1, 2 in the variable that is not all by itself. 0, 1, 2. Okay. Now, this one actually has two choices. You could ask yourself the third question. Does 3 and 1 divide into 3? Do these coefficients divide into the constant? If the answer is yes, you could also solve the problem. You'll get the same line by plugging in 0, 0. Okay. Now let's look at this problem. Do I have a fraction? The answer is yes. What's the denominator? 2. So I'm going to put 0, 2, 4 in the variable that is next to the fraction. Now this one looks a lot like this one. They're not the same thing. This is not a horizontal or vertical line because you have a horizontal or vertical line when you have only one variable. In this case, we still have two variables. So let's walk through and ask ourselves the question. Is there a fraction? No. Is there an x or y by itself? Yes. So what we want to do is we want to plug in 0, 1, 2 in the variable that is not all by itself, the y. On this last one, I don't even bother plotting. If you wanted to, you could just plot 2's for the y's and plug in anything here. That works perfectly fine. What I tend to do on these problems is just use that memory mnemonic that y goes through 2 through the y-axis. Thank you for watching this video.